Good evening, students. So we had to finish certain things, okay, that we left in the morning. Okay, come on, let's start then. Right. Okay. So this was the question where we left in the morning. What is the question like? The question is, if a car okay, so if a car starts with an acceleration of alpha, okay, if a car starts with an acceleration of alpha, travels for some time, then retards with beta and comes to rest if total time in the entire process is t, if total time taken in process is t, then find V maximum and total distance traveled by the car. Okay, there is a possibility they will give you this graph, and there is a possibility they will not give you this graph. So we may have to construct it. So first of all, I will show you how to construct. Okay, so let's erase it first. Okay, now in this one, what we have to find? Distance. Okay, now distance, if you have to find, the best way is to construct VT graph. In fact, the first graph you should construct, if at all you think like you should do it with a graph, then it should be VT graph only. Reason? Because VT graph slope gives you acceleration and area gives you distance. So both the things we can get from VT graph. So we should be going for VT graph. So I am going for VT graph. Okay, so here is VT graph. This is V and this is T. Okay, then what he says, a car starts from zero velocity. So that means graph will start from here. Then what he says, acceleration of alpha. Is it constant acceleration? Yes. So constant acceleration means constant slope. Okay, so constant slope means straight line. So it will be like this. Okay, constant slope, constant acceleration, VT graph is a straight line for some time. Okay, whatever time. Then what? After some time it starts retarding again with a constant acceleration. So again it's a straight line and final velocity should be 0. So it's like this. Then graph is over. Okay, now assume that this is acceleration, this is retardation. Assume that this is up to time t1, this is time t1 here, and this is time t2. Then, okay, acceleration here is alpha, here retardation is beta. That's all. Okay, so now what I am going to do is I am going to just clear this one because we require space to solve. So let's clear this. Okay, now what the question is asking, V maximum and total distance traveled. Total distance is actually area. V maximum is what? Let's see. Whatever the information is given, that you will try to write it and then we will see what we can do. So this is what? This will be V maximum obviously. And this V maximum also we have to find. Okay, its slope is what? This graph slope alpha. Slope means tan theta. If this is theta, then alpha actually is tan theta. Now tan theta means what? This by this. What is this? This is V maximum. This is T1. This is V maximum by T. Okay. Same with this beta. Beta is what? This angle. Beta is that angle. So beta is what? If I say this is phi, so this is tan phi. V maximum by T2. So what we got here? We got T1 equal to V max by alpha, and here T2 equal to V max by beta. Okay, T1 value also we got, T2 value also we got. What is given to us? T1 plus T2 is equal to T is given in the question. The total time in the process is T. So let's put T1 and T2 value. V max by alpha plus V max by beta equal to T. Okay. Now what? Take its LCM. So LCM is alpha beta. And here V max you take common. So V max is here. So what will come? Beta plus alpha. So V maximum value is what? V maximum value is alpha beta T by alpha plus beta. That's all. Over. We got V maximum. Now then, area. Distance means area. And this is what? Triangle. Right? Okay. So let's see what we can do with the distance. Let's just make a boundary here. Distance we are calculating. Now, distance is half base into height. Base is what? Base is T1 plus T2. That means T. So distance is half V max into T. That's it. Yes. So put V max value 1 by 2 alpha beta T by alpha plus beta into T. Finished. Alpha beta T square by 2 alpha plus beta. That's the distance. This is how maximum velocity, this is how the distance is calculated. Clear with the graph? Okay. What next? Next is motion under gravity. Motion under gravity means what? In this one, there is a constant pull of gravity. Gravity of Earth. Where? Downwards. So because of this, we have force downwards. So we always have acceleration due to gravity downwards only. Whether you go up or you go down, it is always like this. Okay. So it is always like this. So first thing that we are going to do is write equation of continuity. Equation of continuity. Now equation of continuity is always used for constant acceleration. Remember, always for constant acceleration. Okay, now we know that V equal to U plus AT. You can write it in vector form also. V equal to U plus AT. Okay, then S equal to UT plus half A T square. Okay, and third one, V square equal to U square plus 2 A dot S. Okay, these are the three equations. And then fourth equation also we can use. What is that? Distance traveled in nth second or distance traveled in tth second. U plus A by 2 into 2n minus 1. So this all we have to remember. Okay. V equal to U plus AT, S equal to UT plus half AT square, V square equal to U square plus 2AS, Snth U plus A by 2 into 2n minus 1. As I said, this we will be using only for constant acceleration. If it's variable acceleration, then integration. We have already done the questions on that. When acceleration is given as 2t, then how to find velocity up at time 3 seconds or time 4 seconds. Right? If velocity is given as a function of time, how to find the displacement. That all we saw. Right. So if variable is given, integration is the only way. If constant is given, then equation of kinematics. Right. So A equal to G, which is always downwards. Correct. And these are the equation of kinematics where we will be using G also. Now if suppose in this one I have to use, so G will be used at what? G will be used as minus J because it's acting downwards. If you are going to see, this is y axis. Okay, G is acting down. So G will be what? Along minus J. Right? Okay. Let's see the questions. Then you will understand it in a better way. Okay. Okay. What the question is? an object is thrown vertically upwards, its velocity and acceleration at topmost point. So what you will do is, when we are going to see its motion, then we will talk about velocity and acceleration at all the points. So suppose that this is ground here and you are projecting the particle upwards with speed u. Okay, what happens? It goes up, reach to the topmost point and then returns back. Okay, this is downward journey, this is upward journey. So in upward journey, if I am looking at the velocity, he is asking what? Velocity and acceleration, right? So when you are talking about this point, where is its acceleration? Acceleration is g only, downwards. Here its velocity will be, let's say, u1, because as acceleration is downwards, so what will happen is velocity keeps on decreasing as it goes up, right? But acceleration constant, g, downwards. When it reach over here, it will be u2, still going up, acceleration still down. Topmost point, he asked. Topmost point, its velocity has become 0. Why? Because if it is having velocity, it will go further up. It's the topmost point. That means it is not going to move further up. That's the topmost point. So its velocity there has become 0. So here velocity is 0. So v is 0. But acceleration still there, g, downwards. Here also. Okay. Now at this point. Okay, at this point here, okay, and then again at this point. What I am trying to show you? I am trying to show you here at this point, velocity will be u2 only, the same height here, velocity will be u2, but downwards, direction is changed. Okay, what about the acceleration? Acceleration is still downwards. It will never change the direction. Acceleration due to gravity always downwards. Okay, here at this height, what will be the velocity? u1, but downwards. At this one, what is the velocity? u, downwards. G is always down. So remember that with whatever velocity you have thrown, if suppose that here velocity and here velocity. Okay, here velocity will be upwards. Maybe it's, let's say, 20 meter per second. So velocity with which this is going to strike is also 20 meter per second. Same height in this one. Okay, under gravity, velocity will be same. Right? Okay. Now what is question asking? Maximum height. What is the maximum height? Okay. So if suppose we have thrown the particle with speed u and we are calculating maximum height. Okay, h is the maximum height. So how to do? We know that initial velocity is u here, and at the topmost point your velocity is going to become 0. Okay, acceleration is g. So what we will do? I am going to use equation of kinematics. Which one? Third one. What it says? V square equal to u square plus 2as. Let's apply 0 u square plus 2. Now acceleration. Acceleration is in the direction of velocity or opposite? It's an opposite. Velocity is upward, acceleration downward, so minus, and this is h. Okay, bring it here, minus u square equal to minus 2gh. So h equal to what? U square by 2. Very simple. Maximum height. Okay, then what? Time of ascent also and time of descent also. What is time of ascent? Time of ascent means time taken to move to the topmost point. Okay, no issues. The time of ascent we will find. So what equation we will use? V equal to u plus at we will use, because we require time. V is what? At the topmost point. This is time of ascent I am finding. Okay, so initial velocity u, final velocity 0. 0. U. Acceleration is what? Is in the same direction to velocity or opposite? Opposite direction. So minus g into time of ascent. So time of ascent is coming out to be u by g. Time of descent. Time of descent means time taken to move from here to here. Now what do I know about this one? Its initial velocity is 0. Time of descent, when I am calculating, my initial velocity here is 0. Okay, what I have to calculate in how much time is going to travel this h. What shall I do? I don't know what is the velocity here, but though I told you that whatever is velocity here, same will be velocity here, but we are not using it. Okay, so then I only know that it is going to travel h distance. So second equation is used. What is this second equation? S equal to ut plus half at square. So how much is S? H. It's a downward journey. H. U 0. Okay, for downward motion, initial velocity 0 plus 1 by 2. Now, is acceleration and velocity in same direction? Yes. Velocity also downwards now, acceleration also downwards. So plus into t square. So what we are getting? We are getting t equal to root over 2h by g. This is your time of descent. Any particle, if you are dropping, how much time it takes to strike the ground? Root 2h by g. Initial velocity is 0. Okay, if you are dropping it, then it will take how much time? Root 2h by g. Time of ascent u by g, time of descent root 2h by g. Okay, but we will say that no sir, we have seen that time of flight is 2u by g. That means time of descent is also u by g. That also we can get, because h value we know already. Put in that one. 2 into u square by 2g by g. See, 2 and 2 gets cancelled. Now what it is? U square by g square. That means u by g. So that is equal to u by g. But actual formula of time of descent is root 2h by g. Clear? All the formulas we have done. All of maximum height, time of ascent, time of descent, time of flight, everything we calculated here. Okay. Let's see what more is there. Question is there. An object loses half of its initial velocity in covering 20 meters. How much more it will travel before coming to rest? It's in vertical motion or horizontal motion? It's not mentioned. So we will not do a mistake of considering this as a vertical motion. Okay, we are not doing it. We didn't say. Okay, so be careful. Okay, let's solve. What is its initial velocity? Not given. Consider u. Assuming initial velocity u. Okay, then he says it loses half of its initial velocity in covering 20 meters. So if distance covering is 20 meters, then its final velocity is becoming half of initial, that means u by 2. This is given. So with this itself, what we can do? We can get one equation, which is third equation of kinematics, which can give us a relation. Okay, we will say v square equal to u square plus 2as. What is v? U by 2. So u square by 4 equal to u square plus 2a into 20. Okay, u square minus u square, that means minus 3u square by 4. Okay, then this is what? 40a. So from here I am getting acceleration value, and what is that? Acceleration value is minus 3u square by 160. That's acceleration. Now question is asking how much more it will travel. How much more it will travel means, or rather before coming to rest, that means final speed is 0 this time. So fine, v dash is going to become 0. Initial velocity I will say u only. Suppose that from beginning itself I am taking. Final velocity 0, initial velocity u, and acceleration is this. Correct? Okay. So what formula? V dash square equal to u square plus 2 into a into s dash. So this is 0. This is u square plus 2 into acceleration is this minus 3u square by 160 into s dash. S dash we are calculating. Bring u square here. Minus u square equal to minus 6u square by 160 into s dash. U square cancel, minus minus cancel, 160 by 6 is s dash. That means 80 by 3. So total distance it is going to travel is 80 by 3 total. But is he asking total from us? He is asking how much more it will travel. How much more? That means it traveled 20 already, in which its velocity became half. Further, how much it's traveling? So further means 80 by 3 minus 20 we have to find. Okay. So 80 by 3 a minus 20, because 80 by 3 is which distance? Total, because initial velocity you consider u and final 0. So total is traveling 80 by 3. But he is not asking total, he is asking how much more. 20 it has already traveled over here. After that, how much more? So 80 by 3 minus 20. What's going to come? 20 by 3. Remember, 80 by 3 also will be there as the answer. Okay. So here answer is what? 20 by 3. I hope everything is clear. So this was the use of third equation of kinematics throughout, here also, here also. Why I did not use it exclusively for the remaining portion? Because one more thing we had to calculate in that. That would have been what is the velocity after traveling 20 meters. It was given u by 2. We could have done that also. Same formula here also. Okay. That also we would have got direct answer. You can do that as well. No problem. Okay. Okay. What is this now? What is the time taken by body to hit the ground? So this is, its height is h. Okay. Initial velocity u, you have thrown it upwards and it's striking the ground with speed 4u. He is asking how much time taken by body to hit the ground. How to do it? You have to find it, right? How can we do? Final velocity given, initial velocity given. So can we use v equal to u plus at? We can use. We can use. But use it vectorially. Why vectorially? Because direction of velocity is changing. If direction is not changing, use it without any problem, v equal to u plus 80. There is no issue in that. But here direction is changing. So that's why we should be using vectorially. So what he'll do, again, we'll say this is y-axis and this is positive for me. That means upward velocity positive, downward velocity negative. So v is what? V is actually 4u minus j. That means it will become minus for us. Okay. And u is uj cap. Acceleration is what? Acceleration is always downward, we know. So g minus j. Okay. Now this j and all that I am not going to write. I will write directly over here. What? V I will write minus 4u. U is u. And acceleration I will write minus. Okay. Now what is going to happen? This will come here. It's minus 5u minus gt. So t equal to 5u by g. How much time it took? 5u by g. That's all. It's over. Nothing more. Okay. But now suppose this 4u is not given. Just take this away. Now the question is asking how much time it will take to strike the ground. Now h is given. H is given. Okay. Now what we will do? We will do in the same way. But this time I cannot use this equation. Then what equation you will use? In which we have h. Second equation. Okay. So what it is? S equal to ut plus half at square. Shall we use vectorially? Answer is yes. Why vectorially again? The reason is you have thrown it upwards, but the displacement is actually happening what? Downwards. It's coming down, no? Correct? So how much downwards? H. So displacement, if I ask, this is initial point and this is final point. So how much is displacement? Minus h. Downwards. So I write minus h. What about u? U is upwards, u only. What about g? Downwards. So minus g. Minus half gt square. Okay, it's a quadratic equation. Okay, minus 2h minus 2ut minus gt square. Minus, no, this is plus. Okay, so minus 2h equal to 2ut minus gt square. Now we have to solve it. Okay, quadratic equation is there, so we'll solve it now. What is going to come? gt square minus 2ut minus 2h equal to 0. Okay, so how to solve quadratic equation? Minus b plus or minus b square minus 4ac by 2a. Okay, so here t equal to minus b. What is b? Minus 2u. This is a, this is b, and this is c. Okay, so minus b, that means 2u, plus or minus b square, that is 4u square, minus 4ac. So minus 4 into a is what? G, and c is what? Minus 2h by 2a. Okay, so 2u plus or minus, this will be 4u square plus 8gh by 2g. Okay, so what time will be there? Time will be taking as 2u plus root over 4u square plus 8gh by 2g. This will be the time. This is what we are searching. Why not minus? Minus is bigger, time will come minus if you are taking, because this value is more than 2u. So if I am taking minus over here, this will come negative. Okay, clear? So that value we are not taking. So this will be the time. How to use it vectorially, I am telling you. Okay, you can break it and solve it, that is also possible. You will say that first I will find time of ascent, then I am going to calculate how much is this height, and then I am going to calculate time of descent. That also we can do. That also we can do, but that will be slightly longer than this one. This is the easier one. Okay, so when velocity is given like this, and if velocity is not given, only height is given, this is how time is calculated. Correct? Okay. What is the velocity at half of maximum height? Easy question. Okay. See that? So we are throwing it from here. This is u, and let this be the maximum height. Okay, and its value also we know. We already calculated. What is the maximum height? U square by 2g. What question is asking? What is the velocity at half of maximum height? What is the half of maximum height? Is this? Let's say its velocity is v here. Okay, how to solve? V is given, u is u, v, they are asking, u is given, and we have something about height also, the distance also. So third equation, v square equal to u square plus 2as. He is asking v, so v square, u is u square only, plus 2 into acceleration, g downwards, u is upward, g is downwards, so minus. And s is half of maximum height. This is maximum height. Half of this means u square by 4g. So what we have? U square, and this 2g, 2, and this is 2, and this g and g cancel. So u square minus u square by 2. So it is u square by 2. So v value is what? U by root. At half of maximum height, what is going to be the velocity? 1 by root 2 of initial velocity. Simple, very simple. Okay. Right. Next. Balloon problem. Okay. A stone is dropped from balloon. Find time taken to strike the ground. Here is a balloon. Okay. This is going up with the speed of 10 meters per second. And height of the balloon is 20 meters. The question here is, when you are dropping the stone from the balloon, what is its initial velocity? Initial velocity 10 meters per second. Why? Because stone in the balloon is moving with that velocity. When you are going to drop it, it will still carry that velocity. It's not that its velocity is 0. Because it's in balloon and it is moving with balloon's velocity. Suddenly how it can become 0? Anybody has stopped it? No. Nobody has stopped it. You have just released it from balloon. So what will happen? It will carry the velocity of the balloon. So this question is what, you know? This question is that here is a building. of height 20 meter, and from here balloon stone you have thrown upwards with speed 10 meter per second. And now you are asking that, and how much time is going to strike the ground? Little while ago we did know that building problem. See, that's balloon problem. So how to do? H equal to ut plus half at square. Now what is h over here? Downwards, minus 20. So minus 20. U is upwards 10. So 10. Then this acceleration minus g. Why minus g? Because it's opposite to the direction of initial velocity. Initial velocity upwards, g is down into t square. Same equation. Minus 40 equal to 20t minus 10t square. Solve this quadratic equation. Answer is there. Same previous question only, no? This one. No, not this. Where it is? This one. Here, if you want, you can put the value also. But I am not saying you to remember this. Not required. Okay? Okay. So quadratic equation we will solve, we will get the time. I am not solving it. Okay? Right. What is this? A particle is thrown upwards, find distance traveled in last second of its upward journey. You can find this question in many of the books when you are solving it. Okay? So here it is. Particle is thrown upwards. Okay, they are throwing upwards with speed v. And what is happening? It's going up, going up, going up, goes to the top and then returns back. He says in last second. Suppose it's taking t time to reach at the top. Last second means what? That means this distance you have travelled in t minus 1 second, and this is the last second. That means 1 second. Last 1 second, how much distance you are going to travel? Correct or not? So suppose in t minus 1 second you reach here, this position here. Okay, in last 1 second you travel to the top. Now let's talk about its downward journey. Okay, in downward journey, this distance it's going to travel in first second. Where it will be? It will be here at the same height. So it means distance traveled by here in last second is the same as the distance traveled in 1 second in downward journey. That's what easy, no? Yes or no? This y. What is y? ut plus half at square. What is u at the topmost point? 0. What is acceleration? G. And time? 1. So what is the answer? G by 2. That's 5 meter. Done. Correct. If you ask in last 2 seconds in the upward journey, in downward journey, first 2 seconds. Okay. Easiest way. Understood that? So upward journey, whatever it's traveling here in the last second, in the downward journey, same distance is traveling in first second. This is how we to do. Alright? Okay. Ratio of distances in first second and third second. Right. If suppose that we are dropping a particle. Okay. From a height we are dropping a particle. Suppose from here. Dropping a particle. So question is asking us, what is the ratio of distances traveled in first second, second second and third second? Okay, no issues. So we'll say first second is travelling h1. First second, remember. The first second is what? h1. h1 is ut plus half at square. This is the general formula we will use. U is what? You have dropped, so 0. You have dropped. So initial velocity is 0. Okay. Half g to 1 square. That is g by 2. That is 5 meter. Now he says distance traveled in second second. The second second means what? Distance traveled in 2 seconds minus distance traveled in 1 second. Distance traveled in 2 seconds minus distance traveled in first second. Or you can use distance traveled in nth second formula. That is also okay. What is the formula? U plus a by 2 into 2n minus 1. So u is what? 0. Acceleration is what? G. N is what? 2 seconds minus 1. So what we are getting? G by 2 into 3. It's 3. So 3g by 2. 3g by 2 means it's a 15 meter. So distance traveled in second is 15 meter. Then distance traveled in third second. So here in place of n you write third. Okay, 3. So let's see that. S third. U is anyhow 0. Then a by 2, that is g by 2. 2 into 3 minus 1. So what we are getting? G by 2 into 5. That means 25. So h in third second. What are we getting? 25. What is the ratio? 5, 15, 25. 1 is to 3 is to 5. The ratio is 1 is to 3 is to 5. So these are the type of questions which are normally asked in motion under gravity, and similar questions will be asked in horizontal motion also, 1D motion. Okay. But these are all we have done for constant acceleration. Correct? What else? Relative velocity. Now relative velocity means what? That concept is what? See, when we are moving, we are always moving with respect to ground. Because ground is at rest. We consider ground is at rest. So whatever velocity we are moving, that is our absolute velocity. That's how we consider it as. Suppose it says that car is moving with 20 meter per second. 20 meter per second with respect to what? With respect to ground. Okay, with respect to ground. But if suppose that two things are there which are in motion. Suppose there is a boy here A which is moving with 5 meter per second and this is 2 meter per second. So I would say that velocity of A with respect to ground is 5 meter per second. Okay, same way velocity of B with respect to ground is 2 meter per second. But if I need to ask, this is velocity, so you can put, and here also if you want to give the direction we can. Okay. Now if I ask you what is velocity of A with respect to B, what B will say? Because velocity of A with respect to B means you are asking from B, what is its velocity that you are experiencing? What is the velocity of A experienced by B? So what B says, if I am at rest, then this is coming with 5. No doubt about that. If this is at rest, this is coming at 5. But since I am also moving, so with respect to me, this is coming at 3 meter per second. That means how much faster this is as compared to this? 3. So velocity of A with respect to B means is velocity of A minus velocity of B. This is relative. Okay. How faster is A? So A is faster by 3 meters per second. What do you did? VA minus VB. That is 5 minus 2. That is 3 meter per second. Okay. Now suppose that one more is there. Suppose here is C. And this C is coming in this direction with 3 meter per second. Now if we ask velocity of A with respect to C, so what C will say now? C will say that if I am at rest, A is coming towards me with 5 meter per second. But since I am also going towards it, it appears to me faster, even more faster, because I am also going like this. If I am at rest, it is coming with 5, but I am also going towards it. Now, if suppose this is also at rest and C is only coming towards it, so what do you say? Is A coming towards, or according to C, is A coming towards it? You say yes. Like in train, what do we say? We have reached station, or station has come. How we use? We don't say that we reached the station. We say station has come. Correct or not? If we are in the train, we feel like station is coming towards us. Correct or not? Right? Exactly same thing. He is also saying the same thing. If this is at rest, then with what speed A is coming towards C? Say 3 meter per second. If this is at rest, if you forget about this 5, and the C is coming towards A, So if I ask from C, with what speed A is coming towards you, you will say 3. Okay, but now here is what? A is also going with 5 and C is coming towards A. So with what speed A is coming towards C? Say 8 meter per second. See? This is VA minus VC. What is VA? 5. What is VC? 3 minus I cap. What it became? 8 meter per second I cap. This is relative. Okay, this is the meaning of relative. This you should be using. See, more I'll show you. This is bus. Okay, in bus there is a person A. Bus is moving with speed 40. A in the bus is moving with 10 meter per second forward. Here is B, who is moving with speed B, with speed 5 meter per second. This is C. Okay, so what we have to do? First thing is, what is velocity of A with respect to bus? You are going to find. Then velocity of A with respect to B. Velocity of A with respect to C. Okay, let's do this. So velocity of A with respect to bus. Now suppose that this A is sitting in the bus. Sitting in the bus, not moving. What you will say? A velocity. What will be A's velocity? 40 meter per second. Along with the bus, it's moving, no doubt. So velocity of A with respect to bus, if he is sitting, he is not moving, will be 0. Okay, if I, for the time being, if I remove this, and this is sitting in the bus. What is velocity of A with respect to bus? 0, because this is also moving with 40 on. Sitting, na? It is at rest. If we are going in a bus, we got a seat. Then what we are doing in the bus? Sitting. We are at rest. So velocity of us with respect to bus 0. But now he is saying that this is also moving with what speed? 10 meter per second. So we'll say velocity of A with respect to bus is 10 meter per second. Okay, said okay. Now suppose if I ask you what is velocity of A with respect to ground, if suppose that some person is here, P, at rest on ground or representing ground. If I ask you what is velocity of A with respect to P, what you will say? Say VA minus VP. No? VA minus VP. But what is VA? Is it 10? No. VA we will find from here. This we have to use first. So let's change it. Find it. VA minus V of bus is equal to 10. What is velocity of bus? Velocity of bus is 40. What is VA? 50. I can use I cap. Okay. Velocity of A is what? 50. Now use. What is velocity of P? 0. So with respect to ground, what is the speed of A? 50. Clear? Okay. Now what was next thing? Next thing was velocity of A with respect to B. Velocity of A with respect to B means VA minus VB. What is VA? Say 50. 50 here. What is VB? 5. So that means 45. With respect to C, now A's speed is 50 in this direction. This is coming with 10 in this direction. Relative is 60. So velocity of A with respect to C will be 60. This is how velocities relatively are calculated. Can they ask like this question? Yes, they can ask. More applications? More applications are also there. What applications we can have? If suppose they ask you that there are two particles, okay, let's say car A is there behind and car B is there. Let's make the question itself. No? Let's solve it and then it will be more clear to you. Okay, so here is one car. This is car A and here is car B, right? All right, car B is, let's say, moving with 5 meter per second, and this is moving with 8 meter per second. Initially, the separation between them is 15 meter. He is asked when it is going to overtake. When A will overtake B. Okay, in these questions we prefer a relative motion. We will use equation of kinematics only, but we will write it in relative form. What is relative form? Nothing. Same way, like V, velocity of A with respect to B, equal to initial velocity of A with respect to B plus acceleration of A with respect to B into T. Same thing. Then position of A with respect to initial position of A with respect to B, initial velocity of A with respect to T into T plus half acceleration of A with respect to B into T square. Same equation, it's nothing in that. Third equation, velocity of A with respect to B square equal to UAB square plus 2 acceleration of A with respect to B into S A with respect to B. Same thing, only relatively we are writing. This will give us the answer. Why we use this? Because otherwise we have to calculate it for B separately, for A separately, and then get the relation. Here in one itself we are getting it. Okay, so see now how to solve it in this way. Our question is, how far is A from B? 15 meter. So that means A has to travel how much more to catch B? 15 meter. So SA with respect to B is 15 meter. SA minus SB, 15 meter. More it has to travel. No? Okay. Velocity of A with respect to B is how much? UA minus UB, that's 3. Any acceleration is given? No, acceleration is not given. So is it mean that they are constant velocity? Yes. So acceleration of A with respect to B is 0. Now SAB is there, UAB is there, acceleration of AB is there. What they are asking? Time. So we'll obviously will go there. Second equation. Use it. The second equation, 15, UAB is 3, acceleration is 0, so we are not writing. T equal to 5 seconds. In 5 seconds, A will overtake B. Right. If acceleration is also given, no problem. If acceleration is also given, no issues. Acceleration is suppose 2 meter per second, and its acceleration is 1 meter per second. No problem. We'll use acceleration also. 2 minus 1, so we'll say 1 into T square. No problem. One more question we'll frame. What question we'll frame? Suppose in vertical motion we are framing one. Okay, one ball you are releasing from here, not releasing, you are projecting, a ball you are projecting, let's say with 20 meter per second. Okay, and another ball you are releasing from here, releasing and dropping. Okay, this height is 20 meter. This is dropped, this is released on 20 meters per second when they are going to collide. Whenever there is a question of meeting, overtaking, two balls are there, two particles are there, we will go for the relative motion. Okay. Okay. So this, its acceleration is there? Yes, G, downwards. Its acceleration, it's a retardation, but that is also downwards only. Okay. What is the distance between them? 20. Its velocity initial known, its velocity initial 0. We know that. Acceleration also known. Okay. So second equation I am using again. What is that? SAB UAB into T plus half acceleration AB into T square. So SAB, that means I am considering this is A and this is B. So how much this has going to travel with respect to B? Consider this is at rest. How much is initial distance between them? 20. Okay. So distance to be traveled is what? 20. Okay. Consider this as at rest. Whichever b is there, no, just consider it as rest. Here also the previous one you see, if I consider this is at rest, so how much is going to travel? 15. That's what we have written. Right? Okay. So here b is at rest. How much it has to travel? 20. So I written 20. UAB. That means UA minus UB. UB is anyhow 0. UA is 20. So 20. Plus half. Acceleration of A, G. Acceleration of B, G. Both downwards. So 0. So T is what? 1 second. After 1 second, both are going to collide. Simple. I didn't calculate how much it's going to travel. Distance traveled by this is x. Distance traveled by this is 20 minus x. Then I kept x value and then nothing. Just this much. Okay. Very common question is there which is asked. Common question is there. One man is there. Okay. And here is a train. A train is here. And the distance between them is d. Okay, train starts with an acceleration a. Train starts with an acceleration with 0 speed only. Okay, starts. Then how much speed he should run so that he can catch the train? With what speed he should run so that he can catch the train? Okay, find minimum speed with which man runs to catch the train. Okay, now let's see that what is given first. Given thing is again, if suppose I consider this is A and this is B. Okay, so SAB is how much? Consider this as at rest. How much it has to travel? D. SAB, D. UAB. Now I have told that this will be running with U. And what is its initial speed? 0. So U minus 0. That is 0. Acceleration of A with respect to B. Now acceleration of A is 0 because this is going to run with that speed only. Okay. So its acceleration is 0 and its acceleration is A. So what you will do? Acceleration of A minus acceleration of B. That means 0 minus A. So that means there's going to be retardation for that. Okay, let it be. Now let's use second equation again. SAB UAB into T plus half acceleration of AB into T square. What is this? D. What is this? U plus 1 by 2. And this is minus A into what? T square. So quadratic equation. Can we solve? Yes. 2D equal to 2UT minus AT square, or AT square minus 2UT plus 2D equal to 0. Okay. One dimensional relative motion. Right? That is it. This is 1D motion. Okay. So go through this, all the concepts, all the questions that we have done. Please go through them and practice. I have already sent it on your app. So go and access the app. You can see the practice test. Solve it. Doubts are there, send me. Each day's doubts, please send me. If I am going to take in this class, fine. Otherwise, we will have an extra class and we will discuss those doubts of yours. Okay, so that's all from my side for 1D motion. Tomorrow we are going to start motion and plane. Okay, students, bye bye.
Sir?
Yeah.
Sir, in previous question, how the acceleration is 0, sir?
Which acceleration?
A.
This is man. Man is going to start running with this speed. Question is find minimum speed with which man runs to catch the train. Okay. Sorry?
In previous question.
Acceleration is there, then how it is minimum speed? If acceleration is there, you are going to have the increase in speed, no? Then which speed you will be finding? When train is going to move, are you going to increase your speed slowly, or you will run with fastest speed whatever you have? You tell me. Okay. So it's not that you are going to, okay, after 5 minutes I am going to accelerate. After 5 minutes I will be increasing my speed. No way, you will lose the train. So you start with maximum speed. Understood that? Clear?
Previous question,
Yes. Yes, sir.
acceleration, how will you do it?
G minus G?
Both same direction.
Axle, both. G is always in same direction, no? Then acceleration of A with respect to G. G minus J minus G minus J. What will come? 0 only, no? Where is the doubt? No doubt in that. Clear? Alright. Okay, students, then. See you tomorrow. Bye bye.
Thank you, sir.